Welcome. In this video, we will create a computer simulation in Python to calculate the answer to the birthday problem. So the birthday problem basically states if you have a group of a certain number of people, let's say in this case 8, what is the chance that at least 2 of them would share a birthday? And it seems to be a little bit unintuitive, so the theoretical mathematics tells us that around 24 people, there's a 50% chance of at least 2 people sharing a birthday, which seems really high. It seems unlikely if you have 365 days in a year that in a group of 24 people there'd be a 50% chance that they share a birthday. So creating a computer simulation to run thousands and thousands of trials gives us maybe a little bit more certainty that this is actually the case. So here's what our finished solution will look like. We can say we want 8 people and we run the trial 10,000 times and hit run, and it will say 7.39% of groups with 8 people had a shared birthday. If we run it again, you'll notice it says 7.72% because every time you run the simulation, it's going to be a tiny bit different. But the bigger the number of trials, the more accurate it will be. We can also change the number of people. We could change this to 15 and hit run again, and you'll see that the percentage chance of a shared birthday in that group increases as well. So for this project, we're going to be using a free online Python environment called Trinket. If you just Google search the word Trinket, you'll get there quite easily. And this is a really fantastic environment for learning basic Python. Once you create more professional things, you'll want to move on to installing Python on your computer. But just as a simple web-based solution, this is very nice. So if you go up, or if you look up the top here, you can see that there's a sign up and login. You can simply sign in with your Google account is probably the easiest way. And then you will be able to just click on whatever your username is here and go to New Trinket and select Python at the top here. Before you get started writing any Python code, there are a couple of things to know. First of all, if you click on this button here and click on a larger font size, it may be easier for you to read. Another thing is that the free version on this website sort of has Python 2 and 3 all mixed in together, and we want to be writing in Python 3 at this stage. So if you go down here and copy and paste this line of code and put that at the top of your program, then it will force the computer to process it in Python 3, which is what we want. Another thing to remember with Trinket is that it does not autosave, so you need to click on the save button as often as you can because you really don't want to lose any work. When you've finished a program, you can click on Share, Link, and copy this link if you would like to share your program with somebody else. So before we start programming, let's think about this problem a little bit more so we're clear in our mind why doing a simulation is useful and helpful in this case. So normally in probability, we can work things out theoretically, which means we don't have to run any experiments. We can simply say, for example, if you're rolling a die, what is the probability of rolling a 3? Well, you could say there are 6 equally likely sides. So the probability of rolling a 3, which is one of the sides, would be 1 out of 6, or 1 divided by 6, which is roughly 0.167 out of 1, or out of 100% is 16.7. Now we could approach this problem with experimental probability, and we could actually take a die and roll it many times, and then we could work out the probability. We'd say the probability of a 3, in this case we got 6 3s out of 30 total rolls, which is 0.2 or 20%. Now you'll notice that's actually a slightly different result, and the reason that we didn't get a very accurate result here is that we only did a small number of trials. If we did 10,000 trials or 1,000,000 trials, that would get more and more accurate until it was pretty much exactly the same as the theoretical probability. So you might say with the birthday problem, why don't we just work it out theoretically? And you can, but as we get more and more complicated with some of these things, the mathematics required to calculate the theoretical probability can get very complicated indeed, and with some problems we might not even know the mathematics. So running a simulation can be a very, very useful way of doing this, especially in things maybe that have to do with nature or genetics or things like this, where we might not even be able to calculate the theoretical probability because we don't exactly know what's going on. So with this, we are not going to run our experiment obviously by going and getting lots of groups of people. We need to generate imaginary groups of people that we can calculate the birthdays from. So let's get into it. So I've done a little bit of setup here. I've put a heading in up the top, or a title for my program up here, and I have imported the random module because we're going to be needing that. It's not built into Python. That will give us the ability to choose random birthdays for people. And I've written out in comments here some of the things that we probably need to do to complete the program. So at the start, I've just got a couple of variables here, the number of people and the number of trials like we saw before, and I've just set them to some numbers. We can change those as we go. Now I've broken down what we're going to need to do into these steps. So I thought, first of all, we probably need a function that can create a random list of birthdays. So if you said, give me 8 people's worth of birthdays, it would send back a list with 8 random birthdays. That's the first thing we need to be able to do. Then we need a function to check whether in that list there is a shared birthday, at least one shared birthday. And then what we need to do is run lots of trials. So we check, 1,000 or 10,000 times in some sort of loop whether the random group of people share a birthday, and then we need to print out the results. So let's go through those one by one. So the first thing I'd like to do is to create a function, have a function to create a random list of birthdays. So we could say def to define a function, and we could call it, for example, create birthday list. And the function probably is going to require some information passed into it. We're probably going to need to know the number of people that we need to create a list for. So I'm just going to say num people will be a parameter that will be passed into this function. Now let's just check that this is working by just say print num people. So if we go down here and actually run this function, oops, for 7 people. Now remember that when we define a function or create a function, that doesn't actually run the function. We have to do that ourselves later on. So right now all this function should do is print the number that we give it. Let's see if that works. Okay, and that does seem to work. Okay. Now let's have a think about what we want this function to do. So we want it to create a list, I would say, and then we want it to randomly put birthdays into the list. So I'm going to make I'm going to just make a list. I'm just going to call it days. So these will be all the birthdays, and it will be an empty list. So in Python, when we use square brackets, that creates a list. And we could, for example, put things in the list, like we could say Jan 45, it's not 45, obviously 25th, etc. But probably the best way to keep track of the birthdays would simply assign a number between 1 and 365. So for example, somebody's birthday might be the 23rd of January. The 2nd of February would probably be 33 because there are 31 days in January, etc. But the point is the months don't matter. We know that there are 365 days. We won't worry about leap years at this point. We know there are 365 days in the year, so we just want birthday numbers in like that. So how do we generate random? How do we generate one random birthday going in there? So what we can say is days.append, and that will put in the list days. It will add this entry random.randint between 1 and 365. Okay, so what this function should do now is it should put in just one random number. Let's print days just to see. Yes, okay, so you can see there's a list with one number in it each time between 1 and 365. But we actually want to repeat this process how many times? 1 for each person, and it tells us how many people in num people. Okay, so let's say for underscore in range num people. Now, I'm not completely going to explain this syntax or this way of writing just at the moment, but basically what this line of code will do is it will take the number of people, let's say it's 7 in this case, and it will loop through this code 7 times, okay, which is what we want. So then anything inside this loop needs to be indented in Python, just like everything inside the function needs to be indented a tab space in as well. But now, if we print days, we should see that we actually have a list of days. So our function is almost working. If you would like to, just for your own interest, if you would like to see yourself, just for debugging purposes, whether there's a shared birthday, you could say days.sort, and then when you run the program, it will actually be put into order. And just for you, it's a lot easier when you're debugging to see whether there is actually a shared birthday. So we might leave that in there for the moment. Now, we don't want to print those days. We want the function to return or give back the list to us. So we'll just say return days, like this. Now, if we go down here and we said print create birthday list, that will call this function and say, I want a birthday list for 7 people, and it will print the thing that is returned, which is the list. So now we successfully have our first function. So the next thing that we need to do is, I'm just going to get rid of this. We don't need to run the function at the moment. The next thing we need to do is we need to create a function that checks for a shared birthday. Now, one way that we can do this is we can take advantage of something called a set. So lists in Python can contain duplicate elements. So we could have 2575, which has the number 5 twice. However, a set has only unique elements. So if you added 2, 5, and 7 to a list, and then you to a set, and then tried to add another 5, it just will say, well, I've already got a 5, I don't need it. So what we can do with our birthday list is if we turn it into a set and the length of the list changes, that means that there is in fact a duplicate birthday. So if we got this in Python and said convert that into a list, this into a set, this would be the result that we would get. So let's use that in our coding. Okay, so we're going to make another function, and it's going to be called check shared birthday, and we're going to have to give this a list. Now, I don't want to actually use the word list because that means something else in Python, so I'm just going to say LST, so that's the list coming in, and the function will check for a shared birthday. I might write the whole word out there. Okay, so what we're going to do is we're going to create a set, and I'm just going to call it st. I'll say st equals, and the way that we turn the list into a set, I believe, is we do that. So we say make a new set out of the list. So now we can run a check, and we can say if the length of the set is less than the length of the list, then we know that there must have been a duplicate. So then we can return, let's return true, because we're checking whether there's a shared birthday. So that would be true. We can just say else, return false. Okay. Now this should work. We can test it out. We can print the result of running this function. So let's say check shared birthday, and let's give it a list of 3, 4, 5, 6. So that should be false. Okay. Now, what if we change the 6 to a 3 here? So this should be true. Okay, so this is working, which is fantastic. Okay, so we should have all the code we need to run our trials. Let's start by running just a single trial. So how would we run the single trial? Well, we'd probably do something like first of all, we'd need a tally. So I'm going to say shared. So that's the number of trials number of groups of people that have at least one shared birthday within them. So we'll set that to that. And then we'll run our first trial. So the trial will look something like, we probably need to make a birthday list. So we'll make a birthday list, and we can copy this. The birthday list, we've already made a function to make a birthday list for us. And how many people do we want in that group? That will be the amount of people we're going to write in the variable at the top of the program. So we make our birthday list. Then the next thing we would do is we would work out, is there a shared birthday? So shared bday, and this is either going to be true or false, right? Will be this function here that we created. And it wants a list that we have called bday list. That's the list we just created there, so bday list. And so now let's just print those two things just to be clear what they are. So if we go and we print bday list, you'll see that it's creating a list like this. And then, print shared bday. So this should be either true or false. So I will run this here. And you can see here that this is in fact false. Let's keep going until we get a true. Okay, is there a shared birthday here? Yes, there is. 233 and 233. And you can see that it's useful that we have sorted them just for our own testing purposes. However, at this point, I'm probably going to comment this out so it won't run, simply because it will perform better not having to make that calculation. If you can strip it out, strip it out. Okay, so now in our trial here, we want to check, we'll say if shared bday, then shared, which is our tally, plus equals 1. Now, we could copy and paste this code for every trial, but it seems way easier to put it in a loop, so we'll use the same syntax that we did before. And I will explain this in a minute. Number of trials. So this loop will run however many we've saved in this variable up here. Okay, so we will go for that. Now everything inside the loop needs to be indented one tab, like this. And everything inside this if statement needs to be indented one tab as well. And let's just print, let's just print shared at the end. So we're going to do 1,000 trials, and it will just print how many of them. So 82 of them did have 82 of the groups that we created did have a shared birthday. Now, I just want to explain quickly what this syntax here means. So this syntax actually goes over a list one at a time, And I just want to show you by printing. I'll get rid of this. I want to show you what the range trials does. Okay, so you can see that we had 1,000 trials. So this actually creates a list of 1,000 elements starting from 0, so 0, 1, 2, 3, all the way up to 999. And then it loops over the list for each element in the list. So what that means is it ends up looping through this code 1,000 times. Now, we could put a variable name here, like I is a pretty common one to use, and that would mean that every time through the loop, we could tell which number or which iteration through the loop is. The first time would be 0, the second time would be 1, etc. if we needed that, but we don't need it. So if we just put an underscore, it just shows other people looking at the code, hey, all we care about is looping over this 1,000 times. We don't actually need to know which loop it is that we're in at the moment, if that makes sense. Okay, so the final thing to do is to print the results. Now, we did sort of print the results before. We just printed how many groups had a shared birthday in it. However, we probably want this as a percentage. So let's make a new variable called percentage, and we're going to set that to the number of groups with a shared birthday divided by the number of trials. So if we had 12 out of 100, that would be 0.12. But we don't want it out of 1, we want it out of 100. So let's multiply it by 100. So that is the percentage. So let's just print that and check that that works. So 6.7% for 8 people. I think that's looking accurate. Let's go and do the 24. Yep, that's pretty close. Now, more trials, the more accurate. So if I put 10,000, okay. Now, when we print that, we probably want to add on some text. So we could say a percentage like this. So 54.41%, for example. I'll put this back to 8 for the moment. Now you'll notice there's an error there. It's basically saying this is a number or a float, which is a number with decimals, and this is a piece of text or a string. You can't join them together. They need to both be strings. So the way that we do that is we just take the float here and get this function which will turn it into a string, and now we are getting the result with a percentage there. I probably would like it to say a little bit more, so I would say of groups, percentage of groups, with, and say how many people it was. So let's put the number of people, which we already have in each group up the top there. And then we'll add the rest of the sentence. People had a shared birthday. Now, there is a more modern way to do this in Python, but it is not supported by Trinket, which is why I'm using the plus, which is sort of a little bit of an old-fashioned way of doing things. So now it says 7.47% of groups with 8 people had a shared birthday. And I think we're done. So you could play around with having different number of trials. If you have a really large number of trials, it will crash the program. So make sure you've saved before that happens. I think 10,000 is probably pushing it a little bit. That's probably as far as you'd like to go. You can change the number of people and experiment. You might even like to try a different number of people and graph it out and see what the relationship is. You might even be able to work out how to create a graph on Trinket doing that. Another thing you could do is choose a different problem, like the Monte Hall or the doors problem. You can look up a YouTube video of how that works. Or, for example, rolling 2 dice, adding them together. What's the chances of getting a 2 through to 12, which is the highest result you could get? It's not even. So you could create a simulation for something else and then check whether your experimental one matches up with the theoretical one. Anyway, I hope you enjoyed the project and don't forget to save. Thanks for watching.